Hello, everyone. Welcome to my YouTube channel. My name is Nathaniel, and I welcome you all to Best Grade Services. Don't forget to subscribe to my YouTube channel, share, and like the video so that others will also come and enjoy this exciting content. Today, I'm going to take us through linear programming models part one, and I'm really going to make it so simple and you will enjoy it. So, let's hop on. So during this lecture, we are going to first introduce the course and I will show you how to construct linear programming problems and also walk you through what linear optimization is. Great. So let's introduce the course. What is linear programming? So when we talk of linear programming, where I denoted with LP, okay, then we are looking at a system that focuses on ways to optimize a field of interest. With that said, let's look at what optimization is. So, optimization is a process of choosing values that maximize or minimize some quantity of interest. Don't worry about it right now. You get what I'm trying to say in the subsequent slides. So, having looked at what optimization is, let's look at what in this slide, I'm going to use an example to make it very simple and for you to understand. So, for example, say firm A produces commodities X and Y. If you are looking for the optimization level of firm A, then we are looking for the right quantity of X and the right quantity of Y that will help firm A to maximize profit or minimize cost. So, really, the importance of linear optimization, the main importance is that it helps in decision making. Great. Let's make progress here. So, now let's look at how to formulate and solve linear programming problems. For you to be able to formulate and solve linear programming problems, one, you should be able to identify the variables or the decision variable, sorry, you should be able to identify the decision variable. Now, what is the decision variables? These are the variables or the unknown variables the model seeks to obtain. Two, you have to be able to identify all constraint functions. And what is the constraint function? It is the function that has limitation. We will understand this as we progress. And lastly, you should be able to identify the objective function. And what is the objective function? It is what I usually call the focus function, or it is the quantity we seek to optimize. Wait, so let's try and elaborate or explain this further using this example. So let's consider these inequalities. Say x1 minus x2 less than or equal to 3 is my equation 1. And x1 plus 2x2 less than or equal to 6 is my equation 2. And z equals x1 plus 2x2 equals my equation 3. So going back to this slide, let's see how we'll be able to solve this linear programming problems. Great. So we have to be able to identify the unknown variables. That is what we term as the decision variables. So now looking at these equations or these inequalities, right? When I take my um equation one, that is x1 minus x2 less than or equal to 3. The unknown variables in this very first equation is what? X1 and x2. Good. If I take my equation 2, x1 plus 2x2 less than or equal to 6. Now, my unknown variables here will be x1 and x2. Great. So taking my last equation, z equals x1 plus 2x2. So now, this equation, the third equation tells us that for us to be able to find z, then we should be able to have the values for x1 and x2. So with these three equations, we can conclude that our decision variable, the variables that we are looking to obtain from this equation, is x1 and x2. Good. So let's move to our step 2. Step 2, we are going to identify our constraint function. So now, from equation 1, x1 minus x2 less than or equal to 3. That means that from this equation, when I combine x1 and x2, I shouldn't produce quantity which exceeds 3. So that means that the maximum I can produce is 3. So it can clearly be seen here that we are constrained. We are limited to the number of quantity that we produce. Good. So equation 2 here also tells us that x1 plus 2x2 less than or equal to 6. So same, it says that when we combine x1 and x2, we shouldn't produce quantity that exceeds 6. So at this point in this equation 2, we are limited. So this makes these two functions our constrained functions. Great. Let's then look at what our objective function is. Back to the slide, we said it is the focus function or the quantity we seek to optimize. And we know what optimization is. Optimization is really to either minimize the variable or maximize the variable of interest. So here, our variable of interest is z. Okay, so when you look at this button, it says that find the maximum and minimum points where z is optimized. So this makes this function our objective function. Good. So now let's walk through how we are going to find these points where z is optimized. So at this point, I'm going to stop the PowerPoint presentation, then I'll walk us through a step-by-step approach. Great. So let me bring my whiteboard here. So I want to have two screens here so that we see what I'm doing. Great. Hope this is visible enough for all of us to see. So I'm going to write all our functions here. So say from the question above, we're given x1 minus x2 should be less than or equal to 3. And this is our equation 1. Then we are also giving x1 plus 2x2 less than or equal 6. This is our equation 2. And lastly, we have our objective function, which is z equals x1 plus 2x2. Great. Now that we have the equation, I will take off the other slide. Then we focus on the note. Good. So let's progress here. The question says that we should find the maximum point that z is optimized. Okay. So we are looking now for the maximum value of x and the maximum value of y. Sorry, x1 and the maximum value of x2. Great. So let's start. So in order to do that, we are supposed to first find the intercept. So first, say at x1 intercept x2 is equal to 0. So now that means from equation 1, so we are focusing on equation 1 first. So say from our first equation. So from equation 1, we are going to get x1. Now x2 is 0. x1 minus 0 less than or equal to 3. So our x1 here should be less than or equal to 3. Good. So from the same equation 1, now let's look at x2 intercept. So let's say at x2 intercept, x1 should be equal to 0 from our same equation 1. So that means that we are going to get 0 minus x2 should be less than or equal to 3. So our x2 here should be less than or equal to negative 3. Good. Hope we are making progress. Now that we are done with equation 1, let's focus on equation 2. So now, equation 2, same as what we did from in equation 1. So from equation 2, we are going to find x1 intercept, then x2 should be equal to 0. So this is our equation 2. We're given x1 plus 2x2 less than or equal to 6. So when x2 is equal to 0, then we are going to get x1 plus 2 times 0 is less than or equal to 6. So our x1 is less than or equal to 6. Good. Now, let's look at x2 intercept. Then x1 should be equal to 0 from the same equation 2. So we are going to get 0 plus 2x2 less than or equal to 6. So we are going to get x2 less than or equal to 3. That is after you've divided both ends by 2. Great. So what we will do right now is to plot the variables, that's the values here, the decision values on our Cartesian plane. So I'll go to a fresh page. So say I have my Cartesian plane here. This is my x1. This is my x2. Good. So back to this slide. Oh, that's good here. So I'm going to have everything here for us to all see. Instead of going to the next page so that it will be very simple for us. So instead of drawing my Cartesian plane on the other sheet, I'm going to draw it here. So same thing. I have my Cartesian plane. This is my x2. This is my x1. So at x1 intercept from equation 1, what did we get? X1 is equal to 3. To say this is my 3. At x2 intercept, that is when x1 is equal to 0. So we had x2 to be equal to negative 3. So say this is my negative 3. So what I will do right now is to draw a straight line to pass through these points. Good. So this is my equation 1. This point is my equation 1. That is x1 minus x2 less than or equal to 3. Great. Now let's look at equation 2. So at x1 intercept, that means that x2 is equal to what? 0. And we had x1 to be equal to 6. So say this is my 6. At x2 intercept, then it means that x1 is 0. So when we do that, then we had x2 to be equal to 3. So should be less than or equal to 3. Sorry, this is my 6 at this point. So I have to erase this. Good. So here I'm going to get x2 to be less than or equal to 3. So say this is my 3. Here. This is my 3 here. So now what I will do again is to draw a straight line to pass through these points and say this is my equation 2. That is x1 plus 2x2 less than or equal to 6. Great. So let's proceed. So now, when we are looking out for the maximum point, then it is the point where x1 and x2 intersect. So really, this should be the point. So I'm going to draw a broken line to pass through this point. So when we are asked to shade the maximum portion from this graph, then this will be our maximum portion. I hope it helps. Great. So now let's look out for the maximum point. And to make it simple, I am going to do that on a table for us to identify the maximum point where x1 and x2 will optimize. That's where z is optimized. Right. Great. So I'm going to do that on the sheet here. Good. So let's proceed. Okay. So at this point, we don't know our decision variable. So we have the firm produces x x1 and what x2. Okay, so let's take this step by step. Great. So let's move on. So say these are our decision variables. You have x1, you have x2, then we have z. So I'm going to draw a table. So now I am going to use equation 1. I am going to use equation 1 here. Another person can also use equation 2. There's no difference, right? You would still end up making the same, getting the same end result. So from here, I'm going to use equation 1. So from equation 1, at x1 intercept, then x2 is equal to 0. So that is what I'm going to plot here. So at x1 intercept, x2 is equal to 0. Then we had x1 to be equal to 3. Hope you are all following. Great. Let me draw a straight line here. Perfect. Then at x2 intercept, then x1 here is 0. Then we had x2 to be equal to -3. Good. I hope we are all following. Great. So now we have 3 unknowns. That is the objective function. We don't know this objective function z. So that means that we have to find 3 variables. Okay. So what we would do right now is we are going to solve equation 1 and equation 2 simultaneously to get these variables here. X1, the last part here, this fill up this page in order to get 3 variables. That's 3 values for S1 and X2. Good. So what we do right now is to solve equation 1 and 2 simultaneously. Right. So now we are going to use method of elimination. So by method of elimination, what we are going to do right now is to do a subtract equation 2 from equation 1. So what we are going to do here, it will be 0, and this is going to give us 2 minus this is going to give us 3x2. Okay, then this 6 minus 3 is going to give us what? It's going to give us what? 3. So we are going to get 3x2, then what? 3. So when I divide that by 3, we are going to end up getting 1. So let me write down. So first, let me make this easy for us. Let's write both equations. So I have x1 minus x2 less than or equal to 3. Then equation 2 has x1 plus 2x2 less than or equal to 6. So equation 2 minus equation 1. Then we are going to get this will cancel out. So we are going to get 2x2 minus x3. So that will be positive. So we are going to get 3x2. And 6 minus 3 should be less than or equal to what? 3. So when I divide both sides by 3, so this will cancel out. So I'm going to divide both sides by 3. So I'm going to get 3x2 divided by 3 less than or equal to 3 over 3. So this cancels. I'm going to get x2 less than or equal to 1. Good. So we found this. So we've gotten x2 to be equal to what? 1. Perfect. So now if x2 is equal to 1, then when I put 1 here, so I'm going to substitute x2, which is equal to 1, into equation 1. So when I substitute this into equation 1, then I'm going to get x1 minus 1 less than or equal to 3. So when I move this one here, I'm going to get x1 less than or equal to 4. So my x1 here is 4. Good. I hope we are all following. Great. So now, let's continue. So now what we are supposed to find is to find our objective values. And then we will be able to identify the maximum points that makes Z optimized. Great. So remember from our equation 3, we were given Z should be equal to x1 plus 2x2. So now, when x1 is 3, when I put 3 here, and x2 is 0, I'll put 0 here. So I'm going to get 3 plus 2 times 0, which is going to give me, so I'm going to put it here, Z is equal to 3 plus 2 times 0, which is going to be 3. So my Z here is what? 3. Good. Let's continue. When x1 is 0 and x2 is 3. So let me erase this. Let me erase this too. So when x1 is 0, 0, and x2 is what? 3, negative 3. So I'm going to get times negative 3. So that is going to give me negative 6. We have minus 6 here. Good. So let's proceed. Let me erase this. Let me erase this. Good. So now, when x1 is 4 and x2 is 1, so I'm going to get 4 plus 2 times 1. So what are we going to get here? We are going to get 6. So now, to answer the question, so I'm going to bring back this. The question reads, let me zoom in for us to all see. Good. The question reads, find the maximum and minimum point where Z is optimized. Okay, so the maximum point where Z is optimized is what? 4 and 1. It's 4 and 1. Because at these points, Z obtained the maximum value. So Z is such that x1 should be less than or equal to 4 and x2 should be less than or equal to 1. Good. So now, let's prove this. In order to know that our answers are correct, that means that if I put these values, that is 4 and 1, into our equation 1, since that was what we used to find the optimum point, that's the optimum point, yeah, we shouldn't get values which exceed 3. So let's prove that. Let's prove that. So now, we had x1 minus x2 is less than or equal to 3. And we had x1 to be what? Let's go back to confirm 4. We have x2 to be 1. So 4 minus 1 is exactly equal to 3. So it tells us that our answer here is correct. Great. This ends our tutorials for today. This is Linear Programming Part 1, and my name is Nathaniel. Don't forget to subscribe to this YouTube channel. Thank you. Bye.